All right, I think we can get started. Hi, everyone. Thanks for joining this event in collaboration with InfluxData. And tonight we're going to kick off the first event, of the 4 event series. We're going to have 4 workshops starting on Monday, and it's going to run for 4 weeks. The topic is mainly around time series database, how to query time series data using SQL, which I think is a pretty cool topic. And also, our, sponsor and also the speaker will be introducing tools for time series forecasting, anomaly detection. For those of you who are into data science, machine learning, I think this is a very interesting event. It happens on May 22nd. And the last event on May 29th is also something I personally very much look into, which is how to build real applications using Python, Flask, and InfluxDB. So this event is sponsored by InfluxData, which is the company that powers, the InfluxDB technology, and it's a very famous time series data analysis, database and tool. So without further ado, let's introduce, in our speak tonight, Anis, who's the InfluxDB developer advocate, and she's going to be the main speaker for the next 4 events. So over to you, and please, kick it off and introduce us to time series data analysis and InfluxDB.
Thank you so much. Thank you for that wonderful introduction and for having me here today. So my plan is to talk about kind of all things time series database and InfluxDB with you all. And let me go ahead and share my screen. Okay, great. There we go. So today's presentation, I really want to focus on the latest version of InfluxDB's new storage engine because it's built on the Apache ecosystem. And what I found really interesting about the evolution of the database was all the design decisions that were made, why they were made, how we made them, and what technologies we used to meet those needs. So that's kind of what this presentation is all about, as a very more so kind of technical in-depth look at what InfluxDB is. Hopefully by the end of it, you have a good understanding of not only InfluxDB, but of the Apache ecosystem and some of the really cool technology that's being built there, so that you can take advantage of it in your projects regardless of what you're doing. But to kind of take a step back real quick, so InfluxData, it's a company that I work for, and my name is Anna Eastotis Georgiou, and I'm a developer advocate at InfluxData. So my job is to create a lot of code examples and tutorials on how to use InfluxDB with a variety of other tools to build applications or monitoring solutions. And InfluxData creates InfluxDB, which is a time series database and also data processing engine essentially, and it has a UI as well, and also Telegraph. And there are open source versions of both, and Telegraph is a collection agent. It's a collection agent for metrics and events. It's plugin driven. It's configurable in a single TOML. Both InfluxDB and Telegraph are downloadable as a single binary. You can, with Telegraph, you can pull data in from over 200 different input plugins that exist or sources, and send them to whatever data store you want as well. And there's a bunch of other different plugins that allow you to do things like aggregate your data, process your data. So if you have a task of needing to get data from one source on a regular schedule and send it or write it to another source, and you want to take advantage of batching capabilities and flushing intervals, and you want a really lightweight agent for that, highly recommend checking out Telegraph. It's also really cool because there's these plugins that are called the exec plugins that make it extensible in any language. So if by some chance those 200 inputs don't meet your needs, then it's really easy to extend Telegraph to meet your needs. So that's a really popular project as well. But today we're just going to focus on InfluxDB and the evolution of it. And I also wanted to take a step back real quick and also just kind of make sure we're all on the same page with what time series is. So time series is just data that has a timestamp associated with it. And we usually think of time series as being 2 categories: logs metrics and events, where metrics are happening at a regular interval and events are happening at irregular intervals. So if we looked in the healthcare space, a metric might be your heart rate, and some sort of arrhythmia would be an event. And we also think of time series data as being logs, traces, and metrics as well. So basically any data that has a timestamp, we consider time series data. And so that's what InfluxDB is used to store. And hopefully through this presentation, we'll also gain an appreciation for why time series is unique, just in its structure, just in the considerations that you have, and how we deal with it differently, and why we rely so heavily on the Apache ecosystem to meet the needs of people that are using time series data. So yeah, the agenda for today is we'll talk about what is the new InfluxDB engine, what requirements does this new engine, what requirements does it have to meet? Let's understand the Apache ecosystem in that context and see how it can meet those needs. We'll talk a little bit about the offering and release timeline. It's already released, so you can try it out right now. And then we'll talk about the SQL support, and that's kind of, you know, a peek into some of the next topics where we'll learn how to write SQL for time series and use that specific implementation to query our time series effectively, and do specialized tasks for time series like downsampling or creating materialized views. And all that means is basically taking our time series data that's at a really high precision raw data and creating summaries that are aggregates to reduce that high precision data to a lower precision aggregate, so that you can retain the shape and the general information of your historical data without retaining as much data, so that you can make it more useful for you. And then we'll also talk about interoperability plans, because that was a huge motivator for rewriting our storage engine. And last but not least, we'll talk about resources to get you started and learn more. So let's talk about the new storage engine that powers InfluxDB Cloud, or InfluxDB Cloud 3.0. So it is built on Rust, and Rust is a programming language, and it's very performant and offers really, really fine-grained memory management. So we'll get into all why we used it later. Apache Arrow is a framework for defining in-memory columnar data, and Parquet is a column-oriented durable file format. So Arrow is the memory format, and Parquet is the file format. And then Arrowflight is a general purpose client server framework, and it's used to simplify the transport of really high network, really large data sets over network interfaces. And then we use Arrowflight SQL specifically to allow you to deliver those really large data sets with SQL. And Data Fusion is an extensible query execution framework that's also written in Rust, and that uses Arrow as its in-memory format. So Data Fusion is also what enables us to query with SQL and query efficiently. And we'll talk more about all of these as we go on. But what you need to know and how InfluxDB pertains to you today, InfluxDB 3.0 is now serving as the foundation for all of our InfluxDB products, and we have various offerings. Most likely you're going to be most interested in the OSS version, which doesn't have 3.0 yet, but it's coming. That's the only thing that's still coming, but you can still try free cloud version right now. And so Cloud Serverless is our fully managed multi-tenant version, and our Cloud Dedicated is our fully managed single tenant version. And there's a free tier of that, so that's kind of the fastest way to get started with it. So let's talk about the requirements. Why did we totally rip? Because before, InfluxDB was written in Go primarily, and so why did we just completely rip apart the previous storage engine and completely rewrite it? Well, it's because we decided that we needed to meet these requirements. The first was that we couldn't have a limit on cardinality. So cardinality is basically the dimensionality of our data. And previously, even though like the index of our data was moved to disk, people are storing so many data points that even that wasn't large enough to accommodate just the huge volume of data that a lot of people need when it comes to time series. Another example of like some of the data workloads that people were writing with InfluxDB is like if you had an R4 4XL instance, you could write like 800,000 points per second with a dimensionality of 10,000 points. So this was in the old version, and we're looking to like vastly exceed that because it's just amazing as you start adding, you know, if you think in terms of the IoT space and you're monitoring your environment, whether or not that's like pressure, flow rate, temperature, concentration, sunlight, etc. As you start growing and expanding and adding more and more sensors, it's just so easy for your cardinality to get really big, especially if you want to include detailed information like location, zip codes, etc. So that was one requirement. And this little table here kind of demonstrates like how each part of the Apache ecosystem and Rust help contribute to meeting this requirement. Another requirement is that we wanted to serve really good performance on analytics queries. Another requirement is that we wanted to have a separate compute from the storage into your data storage, and that the database should use cheaper object storage as its long-term durable store. And that's definitely achieved with Parquet. The fourth one is that we really wanted operator control over memory usage. If any of you have used InfluxDB, you'll know that that's a huge ask. People were always wanting to know about that because it would eat a lot of memory. So InfluxDB 3.0 should offer operator control so that you can control that memory. The other thing we want is bulk data export and import. That comes with Parquet. Parquet is vastly more efficient when it comes to compression than something like I always say CVS, CSV. So yeah, so we implement that. And it's just worth knowing about Parquet in general because you know, if you, for example, want to use Tableau, you can also import Parquet files. You just have to convert them first to a hyper file. For example, I think Power BI, you can import Parquet files directly. So there's like a lot of business intelligence and data analytics tools that are adopting Parquet precisely because of how efficient they are and how easy it makes bulk data export and import. And then we wanted broader ecosystem compatibility. So I talked a little bit about Tableau and Parquet, being able to export your data to Parquet and then upload it or import it into something like Tableau. But we want to be able to provide direct compatibility with a lot of tools. We don't want to reinvent the wheel when it comes to actual data analytics. We want the data scientists and the data analysts to use the tools that we're already using, but just have an optimized database for their time series data. And then that just also makes it easier to pull in other types of data in your analysis, like relational data. Like if you have relational data, that should remain in a relational database, and then you leave your time series data in your time series database and pull them in together, and you can do your work more efficiently. And then last but not least, we wanted it to run at the edge and in the data center as well. You should be able to run InfluxDB on an Arduino and also in your data center. So yeah, and that's still achieved. So now let's talk about Rust in some more detail. So why is Rust important? So Rust is essentially, we want to think of it as a language that empowers everyone to build really efficient software. And when we think about it too, we think of server software, that's where it really shines, less so in the application space, because it has that really long or really large learning curve. But then once you do learn it, you can take such advantage of it in that space that you can really optimize your performance. So Rust is chosen because of that performance and reliability. And for those of you who aren't familiar with it, it's kind of syntactically similar to C++. So if you have any developers, in your organization, or you yourself are familiar with C++ already, then the transition will be easier. However, while it has a similar performance capability to C++, it also compiles to native code, and it has much better memory safety. So memory safety is protection against bugs or security vulnerabilities that lead to excessive memory usage or memory leaks. And Rust achieves memory safety due to its really innovative type system. It also has a system level language, which doesn't allow anything like dangling pointers or buffer overflows. And essentially a dangling pointer is a pointer that points at invalid memory. And they're like one of the main classes of errors that leads to exploitable security vulnerabilities in C++. So Rust helps meet our requirement of not having any limits on cardinality because InfluxDB 3.0 is built on the Rust implementation of Apache Arrow. And we'll talk more about Arrow in a little bit. And Arrow is the in-memory columnar format, in-memory columnar data format. And it's offering that really efficiently is what like allows us to not have any limits on cardinality. And additionally, basically, in order to have unlimited cardinality, it requires, non-trivial CPU during query processing and control over that. So we're really, really reliant on squeezing the most that we can with Rust and by using Rust. And then a second requirement is that we want to provide the best-in-class performance on analytics and queries, in addition to our already well-served metrics queries. And we use Arrow and Data Fusion. These are also both built on Rust. So we're kind of understanding now Apache Arrow is using Rust for a reason. That's also why we're using Rust. Not the only reason, but yeah, it's also the foundation of Parquet as well, I should mention too. So essentially we meet this requirement primarily with Data Fusion and Arrow. And I'll talk more about those in a little bit, but just as a reminder, Data Fusion is the query execution framework. And you can't take advantage of Data Fusion, you can't take advantage of Arrow, which is the in-memory data format, if you're not taking advantage of what they were built on, which is Rust. Okay, the fourth requirement is that we have operator control over memory usage. So you should be able to define how much memory you want to use for each buffering, caching, and querying. We talked a lot about the control that Rust offers. And it's also worth mentioning it has a packaging system that's called crates.io. And it's really, what it really allows you to do is make concurrent programming really easier and eliminate data races. So that's another reason why Rust is like, has another benefit. And if we have more questions about some of the examples or like benefits, oh, it also, Rust, the other thing that it gets a lot of praise for is its async and await capabilities. When that was introduced, I think in 2019, I think that's when people started really getting excited about Rust. Yeah, there's things like buffering. There's like a buffering crate, and that guarantees protection against buffer overflows. There's a cache crate, which ensures async caching structures. And if you want to learn more about like this specifically and Rust, I have a video that I can share a link to later at the end of this. Okay, broader ecosystem compatibility. How does Rust contribute to that? How we have these plans of being able to just plug and play with all these data visualization tools. How do we meet that with Rust? Primarily through Arrow and Parquet. And that story will become much more clear when we talk about Data Fusion and Arrow and Parquet in a little bit. So I'll kind of let that go later. But again, the story is the same here. They're all built on Rust as well, and for all the reasons that I mentioned. And then running at the edge in the data center, if you can optimize your memory usage with Rust, that means that InfluxDB will run better at the edge and at the cloud. So it's kind of self-explanatory a little bit there. All right, so now let's talk about Arrow. So over the past few decades, when we think about data and how it's grown, we know that we have a need to leverage really big data sets to perform, all sorts of increasingly complex business analysis. And this leads to advancements in query performance, analytics, and data storage. And these advancements in these areas are largely due to a greater access to memory. So things like, manufacturing process improvements, demand, and, improvements in memory have all contributed to cheaper memory. And these lower memory costs have spurred the creation of technologies that support OLAP, or online analytical processing, for data warehousing systems. So how does Arrow come into play? Well, Arrow is a framework for defining in-memory columnar data that every processing engine can use. And what it aims to be is the language agnostic standard for columnar memory representation to facilitate interoperability between any data processing engine. And who created Arrow? Several open source leaders have created Arrow, including ones from companies like Impala, Spark, Calcite, and one of the co-creators is Wes McKinney, who is also the creator of Pandas. And for those of you who aren't familiar, Pandas is a way for working with all sorts of data in a two-dimensional structure. It's data scientists love it. I am a huge Pandas fan. I love Pandas. Essentially, Wes McKinney, he wanted to make Pandas interoperable with all sorts of data processing systems. And that's the problem that he had, and that's the solution that Arrow offers. What does it do? It provides efficient columnar memory exchange through zero copy reads. So in other words, the CPU does not copy data from one memory area to a second one. And that reduces the requirements for CPU cycles. Also, the fact that it's columnar based is pretty important, especially for time series. I'll talk about that in a second. But essentially, the fact that it's columnar based means that it makes processing and manipulating data much faster. And Apache Arrow powers a variety of projects that you might already be familiar with. Things like Apache Spark, Parquet, we'll talk about that in a little bit, InfluxDB, Pandas, and just to name a few. So how does Arrow help meet requirement number one, the no limits on cardinality? We want to be able to, write as many series as we can. Well, the way that it meets this requirement is that now you don't have to worry about the type of data you're writing. You can write any type of event data and not have to worry about whether or not your data is a tag or a field. And that's because it overcomes memory challenges associated with some of the large case and large cardinality use cases by providing this efficient columnar data exchange. So previously you had to sit there and kind of design or think in your head, even though InfluxDB is schema on write, you had to decide for yourself, what am I going to make a field? What am I going to make a tag? Because some things are indexed and some things aren't. And if I make the wrong thing indexed, then all of a sudden my cardinality and dimensionality might blow up and then I'm in a hot mess. So you don't have to worry about that anymore. And that's largely because the data is represented by columns and not by rows. And when it was represented by rows, then we had to index some of the rows. So let's talk more about what I mean and some of the advantages of columnar data storage over row-based. So imagine that we're writing the following lines of line protocol. So line protocol is the ingest format for InfluxDB. We had measurements that we can think of those as tables. And then we have these tags. We can think of those as some columns. And then the field is where we'd actually store our actual time series values. So a tag might be the location and the field might be the temperature. And then we have our timestamp. InfluxDB 3.0 will return the following table where the tag sets and the timestamps identify new rows on write when you query with SQL. So essentially, you can query for, you can say select all from measurement one, which is a table essentially, and you'd return this data. However, the data will be stored in a columnar format like this. So this is what we're used to seeing, but behind the scenes, it's stored in a columnar format like this, where we're storing every column. And one thing to notice is that a lot of neighboring values are the same data type and are similar, if not the same value. And this is especially true for time series data, because when we think about monitoring the temperature of a room, it's very likely that that value of that temperature will be 72 degrees for a very long time, and that a lot of our points will be redundant. And so this provides a really perfect opportunity for cheap compression, and that enables some of these really high cardinality or dimensionality use cases. It also enables for faster scan writes by using the SIMD instructions that are found on modern CPUs. Depending on how data is stored, you may only have to look at the first column of the data to find like the max value of a particular field. But if we were to contrast this to a row-oriented storage, you'd have to look at every field, every tag set, and every timestamp in order to find the max field value. You'd have to go across every single one. So you'd have to read the first row, parse the record into a column, and include the field values and results, store those, and then rinse and repeat until you're able to go through all of them and then find the max value. So very inefficient when especially you're working with time series data and you're just like, give me the max temperature value for the day. That's what I'm interested in. Well, boom, you just look at one column and you're good to go. So kind of to conclude this sidebar, the way that Apache Arrow meets this need of meeting really high dimensionality, and the reason why Arrow is being adopted in all these other technologies is because it's columnar based, and that just helps overcome a lot of memory challenges associated with large data sets. So how does it meet requirement number 2? Serve really good performance on analytics and queries. Essentially, you can't have high performing analytics without efficient in-memory columnar storage. So it's a pretty simple X equals X, Y, whatever formula there. Okay, so requirement number 3, we want separate compute from storage and tiered data storage. The database should use cheaper object storage as its long-term durable store. How do we meet this with Arrow? Well, Arrow provides the in-memory columnar format, and Parquet will offer the column-oriented data file format that's on disk. So Parquet and Arrow are both columnar-oriented formats, and they have fantastic interoperability with read and write APIs between the two. Parquet also acts as a much cheaper object store in InfluxDB 3.0. So yeah, they play off of each other. We also want operator control over memory usage. So remember that 3.0 is built on Rust, the Rust implementation of Arrow. So this is how Arrow is able to gain fine-grained memory control over memory usage, and this is how we intend to also extend that control to you. Requirement 6, how does Arrow offer broader ecosystem compatibility? Well, using Arrow as an underlying format allows for really easy data exchange with large and growing Arrow-based ecosystems. There are libraries for Arrow written in C, C++, Java, JavaScript, Python, Go, and Ruby. I think there's more. I think there's more. This ecosystem compatibility is a big reason why, technologies like Big Lake, Spark, Snowflake, Athena have all chosen to integrate it in their stack as well. All right, let's talk about data fusion now. So how does data fusion meet that requirement of no limits on cardinality? Well, just as a refresher, data fusion is the query execution framework that's also written in Rust, and it uses Arrow as its in-memory format. So, if you can store a lot of data in your database, but you can't query it, it's not really that useful, right? So data fusion helps meet this requirement by enabling you to query, process, and transform the really high cardinality data that you can write to InfluxDB with Arrow. And requirement 2, best-in-class performance on analytics and queries. So this is where data fusion really shines. So data fusion is used to execute logical query plans, optimize query optimization, and serve as an execution engine that is capable of parallelization. So a lot of different projects use data fusion. It has a lot of different contributors. It has really broad SQL support, which again, InfluxDB OSS, you can take advantage of Flux, which is a language that's proprietary to InfluxDB, and I really like it because it's kind of reminiscent of JavaScript. It's like as JavaScript and Pandas like had a baby. And it's easy to use, it's fun to execute data that way, but most people just want to use a language that they're already familiar with. So that helps. If you can like get up and running faster, then you can perform better analytics as well. And yeah, that's pretty much all I want to say about this section. Okay, so requirement number 3, we want to separate compute from storage. How does Data Fusion do that? Well, it has the native ability to read Parquet files from object store, and it can selectively read the parts of the Parquet file that are needed. And this selectivity is accomplished through projection pushdown and also object store range scan. So Data Fusion essentially uses really advanced techniques that further reduce the byte requirements. And all these capabilities contribute to really fast query against data stored on cheaper object and separate compute. So that's how Data Fusion is helping there. And then in terms of how Data Fusion contributes to InfluxDB having broader ecosystem compatibility, why do people use Data Fusion in general for this? You know, throughout this whole presentation, I'm gearing it towards InfluxDB 3.0, but you could replace that with any technology that has, you know, these requirements. So Data Fusion supports Postgres compatible SQL and a data frame API as well. So that means that a pandas data frame API, I should say. So that means that you'll be able to support any users that use SQL or pandas data frames. I'm super excited for native pandas data frames support within InfluxDB and be able to query with that. That's not out yet, but that's in the roadmap. And I find that really exciting because and we'll kind of learn about this in a later talk, so many of the best, in my opinion, packages and libraries for working with time series are in Python and utilize, you know, data frames. There are quite a few written in R, but even more really widespread and really well adopted ones are written in Python. So if you're doing time series data analysis or time series data science, worth looking into Python. Okay, let's talk about Parquet and how it meets these requirements. And let's first just talk about what Parquet is. So Parquet files are a compressed columnar, surprise, data format. So that's another key kind of point for this whole thing, is that there's a, you know, huge push towards columnar oriented data formats. I just wanted to give some stats about like comparing Parquet to CSV files. So when you're converting 1 terabyte CSV file to Parquet, the file size is reduced to 130 gigabytes, which is an 87% reduction. Crazy. Query runtime is reduced from 236 seconds to 6.78 seconds. So it's about 34 times faster. The amount of data scanned for a query can drop from 1.15 terabytes to 2.25 gigabytes, which is a 99% reduction, and the cost reduction is around 99.7%. So you might be asking yourself, what is the secret sauce, right? What makes Parquet perform so much better than CSV and other file formats? So one is the run length and dictionary encoding. So I kind of mentioned this already or alluded to this with columnar data. Rather than storing the same value on disk many times, which effectively is just wasting space by storing the same value over and over again, Parquet is able to simply list how many times that value appears within a column, which results in a massive space savings on data sets where the values are repeated frequently. And this is especially true for time series data. Another thing that it does is record shedding in assembly. Essentially, there is these map nested data structures, and there's a really good paper, Google's Dremel paper, which talks about this specifically. And it basically just allows developers to treat their data in a natural style while getting more of these benefits from it being columnar. Also, there's really rich metadata as a result. Under the hood, Parquet keeps tracks of large amounts of metadata, which make all these above strategies and like all the advantages of this columnar data possible. Data is broken into row groups, column chunks, and pages, for example. And all of this complexity is abstracted away, so developers don't have to worry about it. But yeah, rich metadata paired with columnar is kind of the secret sauce. So how does it offer best-in-class performance and analytics on queries? Well, since Arrow and Parquet are both columnar data formats, they increase the performance of all, aforementioned associated benefits. Parquet offers really good compression, and it also supports a bunch of interoperability with other analytics and machine learning tools. I mentioned Tableau and Power BI already, but I'm sure there's more and more that are adopting or integrating Parquet as well. Those are just the two that I've played with. So separate compute from storage. Parquet files take very little disk space, and they are the disk file format. And they have the very fast scan rates because they're column oriented. So we've already talked about this already. Another fun fact is that they are 16 times cheaper than CSV files when we're talking about RAM. So they help prevent any bottlenecks, also resulting in disk IO. And kind of that has pushed that those bottlenecks have pushed the need for the separation of compute and storage and really efficient disk file format. And then bulk export and import. This one should hopefully, we should understand already, even if we only understood that Parquet is a really, really efficient or much more performant CSV, then hopefully that kind of answers itself. Broader ecosystem compatibility. I think I've mentioned already, it offers interoperability with a lot of modern ML tools. And then Data Fusion also supports a SQL and Pandas data frame API. And you can really easily convert Parquet to data frames as well. And that just makes working with the data that, in my opinion, that much easier, just because you have so much more flexibility when it comes to working with pandas and analyzing data that way, and using all the different libraries that use pandas as well. Yeah, you can convert Parquet directly into pandas data frames. Oh yeah, Databricks another example. Athena, Snowflake, for broader ecosystem compatibility with Parquet. And then run at the edge and in the data center. Because they're so efficient, that means there's greater capacity for data storage at the edge. Yay. So some other fun things. This is what the UI looks like. It's really only meant for exploring your data, not doing your heavy analytics, not for making dashboarding tools. Go take advantage of the interoperability and do that elsewhere. But it's pretty cool. You can, now do things like create scripts and save them. You can query in SQL. Oh, and you can also use this query builder on the left-hand panel to, build the SQL query for you. We're also, some of the other developer advocates, we're just finishing up our project where we wrote the Python CLI for 3.0, and we integrated ChatGPT, everyone's favorite topic as of late, so that you don't even have to learn SQL and you don't even have to use a query builder. You can just ask in native English and it will return a SQL query for you. So that's fun. And yeah, here's just an example of, running some SQL, where we are selecting for sensor ID and temperature and time from a table / measurement called air sensors, where we specify a particular time range and we return our data. We have a lovely time series represented there. And these are all the SQL functions that are supported from January 31st is when we first released it, but there are many more. Pretty much all of the SQL functions that are part of Data Fusion should be supported. We just haven't tested all of them yet, but there are many more than that. And then we already have interoperability with Apache Superset and Grafana, and I believe Tableau Desktop, but we're still looking for interoperability with Tableau Cloud and Power BI, although, and then coming soon to be able to query Parquet directly so that you can, in the case of Tableau, convert it to a hyperfile, which is pretty easy, and then import it into Tableau or import it directly into Power BI. So how do I get started? You can scan the QR code there and get up to date and get started with InfluxDB 3.0. But also, if you have any questions about Apache, about Parquet, Arrow, etc., please join us on our community Slack workspace. We are happy to talk to you about all things time series. And feel free to join our InfluxDB_IOX. IOX is what the engine was originally called because it stands for iron oxide, which is rust. And so yeah, so join us there if you want to talk about 3.0 specifically. Then Influx community is a GitHub org where the DevRels, other developer advocates, and I have a bunch of different projects that use InfluxDB. So if you're curious about it, head over there and see different examples. And then also you can get started on our website. That's redundant. Excuse me. Yeah, feel free to get it, try it there. And then here are links to a bunch of different related blogs if you want to learn more about this, and I'll share links with you in a little bit. And some more resources. We have our Slack. We also have our documentation, our blogs. InfluxDB University is where you can also take courses on InfluxDB and Telegraph. Telegraph is that collection agent, and earn badges. So that's a fun resource. And then also the forums. I primarily answer questions on the forums. So if you want to talk to me, I'll usually be there instead of Slack, but there's plenty of really capable active community on Slack, so I recommend going there as well. And let's see, I think we have some things in the chat, but if anyone has any questions that they'd like to drop, please let me know. I'm going to stop sharing my screen for a second just so I can share some of those links with you in case you want to read more. But thank you so much for joining, and yeah, feel free to ask any questions that you might have.
Thank you very much, Anais. Hey guys, do you have any questions? Feel free to unmute yourself and ask questions, or you can send your questions and comments to the Zoom chat.
Was ORC considered as an alternative to Parquet? That's a really good question. I don't know the answer to that. I'm actually supposed to interview our CTO and founder, Paul Dix, about his decision to use Rust and some of this underlying technology, and I'm going to include that in that question. And also, I will also on the forums save that question, get an answer to it, and post it there so I can ask. Thank you. But I'm assuming it wasn't just because I don't know, actually. That's a really good question. So he also asks, this seems to be a competitor in the data lake space because of column-oriented focus. Data warehouses are more cube-based. Do Hudi, Iceberg, Delta Lake formats apply at all? I would agree with you. I do think it is more of a competitor in the data lake space with the emphasis being on time series specifically, just because when you're working with time series, there's certain functionality that you need that you don't want to have to build out of the box, like things like downsampling your data, working with time zones, shifting time, converting time, things like that. So, and then also ways to really efficiently store logs, traces, and metrics. So we meet open telemetry standards with our Telegraph plugins. Actually, there's a really fun, hold on, let me give you that. This is a really fun demo. Okay, so those are, I didn't finish collecting all of those resources, but those are some of them. Here is a fun repo, the last link I just shared, on a demo that showcases how you can create logs, traces, and metrics from a sample application from Jaeger. Jaeger provides a sample application, it's called Hot Rods, and then you send them to InfluxDB with Telegraph using the open telemetry standard, and then you can visualize the traces in Jaeger and logs and metrics in Grafana, so that you could, monitor your application. Then he asked too, do you know if Looker, AWS QuickSight, GCP Data Studio will be integrated? I think that eventually is the plan. I haven't heard specifically about those integrations as of yet because we're still focused on some of the other ones, but I think that is kind of the long-term plan. Don't quote me on that though. I don't think the product roadmap has made up that far. You mentioned supply chain use case, which is a pretty big on the time series data and demand forecasting. Can you give some other industry use cases at a very high level? Sure thing. We have DevOps, we have energy, especially we have a lot of customers in solar panel and alternative energy. We have people also in the agricultural space, and in general, like pretty much any manufacturing as well. And then predictive analytics, obviously. Okay, we have another question coming into, does Influx support streaming visualization like Power BI offers? No, our UI is very bare bones. We're trying to push, it used to be a lot more fleshed out, but we're trying to now push people towards the tools that they already use. Thank you guys for all these really good questions. I appreciate it. MIT. Oh, what OSS license? Here is a link to that. Comparison to AWS time stream. That's fun. That is a competitor. I actually haven't used AWS time stream that much. I think a big, difference is that we are open source, and the ability to use OSS instances and then consolidate the data into a cloud version, and where we're also not locked into using AWS tools, and you can really easily expand to other tools is, that's kind of what we're trying to offer and are some of our competitive advantage over AWS. Because yeah, ideally, you could run it at the edge, and then consolidate in the cloud and then use whatever tools you need on top of it. Support for procedural SQL like PL SQL or T SQL. So we use Postgres, implementation of Postgres SQL. I don't know if that answers your question because I actually don't know what the difference like PL or T SQL is. Do you embed Influx SQL into a language like Python? InfluxQL. Oh, you can also query with InfluxQL. I think that's what this person is asking. I'm not sure. So there is a Python client library, and right now it's used primarily for writing data to InfluxDB. Hold on, let me give you links before I just start talking. Bad habit of mine. You can find it on Influx community. So in here you can find all sorts of examples. Ooh. For querying and working with Python. And yeah, so you can provide a SQL query, and then it utilizes the Flight SQL library to query InfluxDB 3.0, the Python implementation of the Flight SQL library. Oh, let me give you another link too, in case you're interested in other languages. There's examples here. I'm working on C++ right now, but using the Aeroflight SQL library for Go and Java. And I'll add Python like later this week because we already have examples for it in other repos, but I'm trying to consolidate everything. So does Influx use Calcite as a SQL parser? I don't think so. I don't know if Data Fusion uses it. Let's see. I want to say no because I haven't heard of it, but oh, what? Maybe. I don't know. Oh, looks like it's a discussion. So, yeah. So the question is, I don't know, but that's a good question. I'm curious to find out. You guys are giving me the best questions, and I really appreciate you for it. Support for C#. I do believe that there is a Flight SQL for C#, so that means theoretically there should be. Okay, and talk about the next 3 events. So next one, querying time series data with SQL. If you're new to SQL, recommend this. It also, like, our implementation of SQL is a little wonky. So there's like a couple little gotchas, but you know, if you use the Python CLI that I linked to above, then you could just like query in English. So you don't really have to worry about it, but it's still, you know, worth understanding. So that's what we'll talk about in the next presentation, and that's especially useful if you're not that familiar with SQL. And then the time series workshop, time series forecasting and anomaly detection. I'll share my favorite libraries, what I use them for, kind of overview of their methods and where they shine, and some of the competitions that they've been used in and how they excelled. And then the last one is kind of self-explanatory, building an IoT application, specifically one that monitors the health of your plant with Python Flask and InfluxDB. Can Influx run containerized? Yes, both to both. If you look at our website, there's instructions for that, for the install, and also yeah, there's oh my god, I can't remember the name right now, so ignore me, but the answer is yes. And hold on, I just want to write down some of your questions because they're so good, and I want to make sure I can answer them in the community.
I think keep the Zoom window open for a while so I can write down the links.
Thank you.
Can you keep the Zoom open for a while?
Sorry, what was that? I can't hear you very well.
Can you keep the Zoom window open for a few minutes so we can write down the links before you close it out?
Oh, sure.
Okay, thank you.
Of course. Yeah, that ORC question, that's a great question.
And just so everyone knows that the event has been live streamed to YouTube. You can go to youtube.com/@WeCloudData to watch the recording as well.
Oh, and also for the person asking about the Docker and Kubernetes operator, yeah, I really recommend looking at that example of InfluxDB observability. That's all run in containers and feels pretty, it's a meaty demo that's really easy to run. So yeah, go give that a look-see for ops monitoring. Yeah, we don't offer that many dashboarding tools out of the box. Those, yeah, people want to use Grafana, so that's what you should use, Grafana and Jaeger for those. Does it work with ETL pipeline tools? Not directly right now, but that's the goal. I mean, other than like, you know, using client libraries and APIs. All right. Yes, you can stream data into InfluxDB with things like Kafka. Who was it? Hulu does that. Here's a fun blog about that. Oh my gosh, you're so right. Sorry. I think it's through Telegraph. I was thinking about the old storage engine, but through Telegraph. Influx right now will be able to import Parquet files directly. It doesn't right now. Right now, the only ingest format is line protocol. Roadmap for future releases for OSS. I don't have the timeline on me. I wish I did. Ask in community and ask on Slack, and someone will be able to give you a better answer, probably. Yes, there is. Influx offers it. I'm not sure what you mean there. You can look at price. The 3.0 version for enterprise is still coming. That's almost out. Here it's, yes, hosted version, all the all the big players. Yeah, if you look at the link I just sent you, there's all the details on the offerings and the marketplaces and what you get for security compliance and scaling and such like that. That's also in the same thing. I am not strong on my knowledge on security. So I'm not gonna answer that question. As someone who deals with a lot of people that have hobby projects in the OSS world, doesn't come up as much.
All right, cool. I think it's 7:05 now. I'd like to thank everyone for the great questions, and of course a huge shout out and thanks to Anais who's presenting this topic today and also in the next 3 weeks on Monday. So yeah, we very much look forward to the next event where we're going to talk about how to use SQL to read and analyze time series data with Influx data. So thank you so much for your presentation tonight, and we learned something new, and we look forward to the next one. And thanks everyone for your participation.
Okay.
Have a great evening, everyone. We'll see you guys next time.